The special variations on simple increase and simple decrease formulas for exponents is actually doubling time and half-life. And so with doubling time, it's a measure of how long it takes a population to double, or so to increase by 100%. Okay, and so in this case, the formula is going to be P is equal to PO times 2 to the exponent T divided by D. So P represents the final population of whatever it is you happen to be studying, and that could be people, or it could be the amount of money that you have, or it could be um, the amount of caffeine in your system, or whatever. Okay. PO is the initial; it's your starting value. So PO is simply your A value. The 2 you'll recognize here in the equation. That 2 is representative of 200%, so getting to a doubling the initial population. T is time in whatever unit you choose to use, and D is the doubling time that will normally be given to you. The real key thing in terms of doubling time and also for half-life is that you have the same units for time, for both the time and in the doubling time. They have to be in the same unit. Doesn't matter if it's in seconds, hours, days, years, minutes, decades, whatever, but it has to be in the same unit of time. The half-life formula is again very, very similar. And so with half-life, it's how long it takes for a mass to be cut in half or to be divided in half. And this is usually done with things like radiation studies, or the amount of time it takes for a certain drug in your system to dissipate by half, or the amount of flies in a population to potentially die by half, or something to this effect. Okay, and so in this case, you're looking at a final mass is equal to its initial or starting mass. That's what MO means. And again, MO represents your A value, your starting value. And then you'll notice you've got 1/2. So up here in doubling time, we had, this represents 200%. And with 1/2, another way to write that is just 0.5, and that's representing 50% of your starting population. That's why it's in there. Okay. And again, time and half-life are again in the same unit. Okay, so you'll be given time and you'll be given half-life. So the key thing there is to identify uh, what it is you're trying to figure out in the end, and then to recognize whether or not it's going to be a doubling time or half-life time question. And usually the words doubling time or half-life would appear in the word problem to kind of cue you in as to which formula you need to use. Okay, but these are both variations on formulas for either simple increase or simple decrease.